Let's study 10th standard ICSE physics, chapter 4b, refraction of light through a prism. If you look at the diagram of a prism, it has totally 5 faces. These are the refracting surfaces, this is the base, and this is the refractive edge. But when we draw diagrams, we don't have to draw a 3D diagram, we just draw a two-dimensional slice of the prism, which is a triangle. So if you look here, the incident ray, when passing from air to glass, bends towards the normal. So this was the original direction, but it has bent towards the normal. And then again from glass to air, it bends away from the normal. So it's bending towards the base. So remember this, it always bends towards the base. Now, interestingly, here the angle of emergence may not be equal to the angle of incidence, which was the case glass slab. And here we saw that the incident ray is parallel to the emergent ray. There is no deviation, just lateral displacement. Another major difference is prism can cause dispersion of light into 7 colors. Now the reason why here the emergent ray is not parallel to the incident ray is simply because the refracting surfaces are not parallel to each other, which was the case in a glass slab. Now there is one formula we need to remember. Now what are the factors affecting this angle of deviation? First of all, let's talk about the dependence of angle of deviation on the angle of incidence. If you do an experiment, we'll notice that initially when the angle of incidence is small, let's say 30 degrees, the angle of deviation is larger, which is 47 degrees in this case. Now if I increase this angle of incidence, the angle will start decreasing. There will come a point when the angle of incidence is such, in this case it's 48 degrees, that the angle of deviation will reach its minimum value, which for glass is 36 degrees for glass-air combination. Which means if I increase the angle of incidence further, let's say to 70 degrees, then the angle of deviation will increase once again, which is 43 degrees in this case. So if I plot a graph with all these values, it would look something like this. So initially, as the angle of incidence is increasing, angle of deviation decreases, it reaches the angle of minimum deviation, and then if I continue increasing the angle of incidence, the angle of deviation won't continue decreasing, rather it will start increasing. So this value of the minimum angle of deviation is called angle of minimum deviation. And the position in which the prism is kept, you see, it's easy to rotate the prism rather than change the direction of this laser light. So that position when we get the minimum deviation is called, no points for guessing, position of minimum deviation. And the formula for angle of minimum deviation is 2i minus a, which can be derived from this equation because something very special happens when the angle of deviation is minimum. I becomes equal to e. Otherwise I is never equal to e. Only when the angle of deviation is minimum does I become equal to e. Another special thing which happens when the angle of deviation is minimum is that the refracted ray inside the prism becomes parallel to the base of the prism. Now this is in case the prism is isosceles or equilateral, then only. Now remember, for glass and air, the angle of minimum deviation is 36 degrees for an equilateral triangle, and when the angle of incidence is 48 degrees. The second factor which affects angle of deviation is the material of the prism, or the refractive index. If the refractive index is greater, the angle of deviation will also be greater. Next, it depends on the angle of prism A as well. As A increases, angle of deviation will also increase. And finally, it will also be affected by the color or the wavelength of light. Since the refractive index for violet color is greater, so the deviation for violet color is also greater. Out of different colors, the deviation for blue is maximum and the deviation for red is minimum. Blue bends. Of course, violet will have even more deviation. Figure 4.31 is double ticked, so that has to be practiced. Even figure 4.29 has to be practiced. Read the question in the theory part and practice a diagram. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.